Jeet's grown some carrots. He plants 28 carrots, but only 12 grow. The probability of one of my carrots growing is 3 over 7, he says. Show that this is correct. Well, the probability is we're going to be interested in the total. It's only a one marker. We're interested in the total number that grew. So we had 12 divided by the total number that were planted. So that's going to be the probability. And then I just want to cancel this down, and I can see that 4 goes into both of them. So it's going to become 3 over 7 as required. I think that's enough. As long as I've got that fraction 12 over 28 and I set it equal to 3 over 7, that should be sufficient. A farmer uses this probability to calculate how many carrot seeds he should plant to grow 10,000 carrots. How many seeds should he plant? Okay, I like it. So we, when you, like, let's say, I'm just going to talk about this problem in a bit differently. Let's say I was, I rolled a dice, how many times should I roll it? 600 times. And I was interested in the number of times I'd get a 1. Then what I would do is work out the probability of getting a 1, which is 1 over 6 on a fair dice. I'd multiply that by the total number of times that I'm rolling the dice, and then I'd work that out, and I'd expect to get 100 times. So I'm going to use the same principle here. For me, the probability is 3 over 7, but this time I want to know how many I should plant times by 3 over 7, and that is going to equal 10,000. So this is like a reverse fraction problem, essentially. Do you know what? I've thought of another way of doing it. Okay, no, I'm going to stick with this way for now. So if I wanted to know this, I could then do 10,000 divided by 3 over 7, and then I can work out what that is. 70,000 divided by 3, 23333.3 recurring. So how many seeds should he plant? I'd go with 2, 3, 3, 3, 4. I think that'll be accepted along with 3. As long as I've got this bit of working here, that's enough. Now, I did start talking about another method I could use. Right, I like this method actually, and it doesn't involve sort of division in the same way. I've just realised, but so both are fine. 1, 2, 3, 4, 5. Right, I've split. I know that I've got 7/7 of seeds, and I know that 3/7 is worth 10,000, and I want to know what the full amount is worth. So what I can do is I can work out what just 1/7 is worth, and I can do that by doing 10,000 divided by 7. Sorry, 10,000 divided by 3, apologies. Okay, and then I can multiply that by 7, and that would take me back to my answer. So it's just another way of thinking about it. If you like the sort of diagram way, I mean, this is more algebraic, writing down an equation that you recognize, but realizing that it's the missing bit here we don't have, and then dividing through. This is more of a visual approach, splitting it into sevenths, realizing I've got 3 of them, it's worth 10,000, working out what 1/7 is worth, and then timesing that by 7. Both are fine as long as you get this as the final answer. Explain why it may not be sensible for the farmer to use Jeet's experimental data to calculate the number of seeds he should plant. One thing is that Jeet's sample is very small. If I only go and interview, 5 people about what they think about some chocolate or something, that's not as good as if I interviewed 1,000 people, say. So Jeet's sample is small, would be one thing. Another thing was, even if his sample was really big, Jeet is growing carrots in his garden, whereas the farmer is growing them, we don't actually know, but it could be different. It could be different conditions. So I'm going to leave it as that because it's a 1 marker, but I'm just going to say this one verbally. You could instead say the farmer's conditions in his field may be different than Jeet's conditions in his garden.